Okay, we're doing the last page of the 2.3 notes for Algebra 2. This is Mr. Peterson. And what we're going to do here is we're going to factor out the greatest common factor to start with. And you pick on the little guy. The only numbers that go into 3 are 1 and 3. You won't use the 1 when you're doing this. So these all divide by 3, and you're going to start by doing that. You're going to pull that out and say this one divided by 3 is 4x squared. You could check by distributing here and you'd be right back where you started. Plus 12x divided by 3 is 4x. So you can see this when you multiply gives 12x. And then 3 divided by 3 is 1. So we get 3 times this. You can check this step by distributing across and you'd be right back where you started. Okay, then we notice that there's a perfect square on each end. This is 2x times 2x. This is 1 times 1. And when you multiply those numbers, 2x times 1, and double it, you get the appropriate middle number here. So this one's ready to factor. So what you do here is you use the square roots of each end. Square root of this would be 2x times itself gives 4x squared. The square root of 1 is 1, since 1 times 1 gives 1. And then you use the sign from the middle term both times, and then you write it as a perfect square, which means you take the repeated factor and you use an exponent to express that instead. Okay, this last problem here on that section, example 20, we're going to begin a new section down here, actually has a typo, so we need to fix this. And you can see I left the 0 out of that middle one, so let's cross this out and use the correct version here. Okay, so the numbers that go into 24 are 2, 3, 4, 6, 8, 12, and 24. And the biggest one that goes into all of these is 6. 6 divides into all of them. You can try 8, it doesn't work. You can try 12, it doesn't divide into 150. 24 doesn't divide into 150. So 6 is the biggest number that works, along with an x, insertion x, all the way down here. However, anytime you have a leading coefficient that's negative, you want to pull the negative version out. So that's what you want to pull out. Anytime you have a negative up front, you want to pull a negative out of it. Okay, so negative 6x times 4x squared would give this one. And negative 6x times negative 20x would give positive 120x squared. And then negative 6x times positive 25 gives us 150x. If you take this divided by this, you'll get that. Okay, so maybe you can see we have perfect squares now on the end. And I'm going to break this apart now. 2x times 2x is how you get your 4x squared. 5 times 5 would be your 25. And then you always steal the middle sign when you do this. And I'm running out of room here, so I'm going to come up here with it. It's going to be negative 6x times 2x minus 5, and you put an exponent on it to express the fact that you're multiplying that same thing twice. Okay? All right, the last type of factoring. This is a very easy style. You're looking for a difference of two perfect squares. It's called difference of squares. They don't actually say that word. And difference means subtraction. So the format that you're looking for is a perfect square in front, a perfect square in the back, and a minus sign between them. A difference of squares. Okay? So let me give an example here. This is a pretty simple one. That's a perfect square. It's 5x times 5x. behind the minus sign is a perfect square. That's 7 times 7. And you have a difference or a minus in the middle. And these are very simple to set up and to do. You simply use a plus sign and a minus sign. And then you put the square roots in. And you're done. You can't combine these with an exponent since they don't match. Up here, when they matched, we were able to use the exponent to express it. You can't do that down here. Now let me check it. I'll show you that it works. This gives 25x squared. You get a 35x in the middle and a minus 35x on the outside. Those cancel off. And you get a positive times a negative here, negative 49. Which, by the way, is why these are shorter. The middle term will cancel off because they're opposites. And because you're multiplying opposites here, you always have a minus sign down there. Okay, here's another example of that. This one is 6m to the second times 6m to the second. The back one is 5n times 5n. So we just start out with the plus or minus sign here. Always plus or minus. And you go 6m squared times 6m squared. That gives you 36 to the fourth. 5n and 5n. Okay, I can disguise these with greatest common factors, and this one has a 6 hiding inside of it. These both divide by 6. So we're going to pull the 6 out. And once I do that, the mask is off. There's your perfect square, and here's your other one. So now I keep that 6, and I put a plus and minus sign in this. X times x to get the x squared, 3 times 3 to 9, and everything works. Remember, if you negative GCF out, the negative version of it, and these are both hiding a 2 and an x, so I'm going to divide these by negative 2x. And when I do that, you're going to see the mask come off of this thing. It's going to be a difference of 2 perfect squares. So now we write plus and minus and put the square roots in. 2x times 2x to get my 4x squared, 3 times 3 to get my 9. And that's it. That's the answer. Now, it is important to know in this section that a sum, plus sign, of squares doesn't factor. It's prime. So I'm going to show you different ways people attempt to factor this one, but I'm going to show you why they all fail. Some people try to go 6x plus 5 and 6x plus 5. That's probably the most common. The problem with that, I do get this 36x squared. That works. And I get a 25 right there. But there's a 30x hidden in here and another 30x hidden in there. So it would really look like this. And the 60x comes from a 30x added to another 30x. And you can see that that's very different than this one. So that didn't work. So now I'm going to try 2 minus signs. And we have the same problem here. This gives 36, oops, I need a 6 there. This gives 36x squared. And but then we have a minus 30x and a minus 30x, so you've got this unwelcome middle term here. Negative 5 times negative 5 turns out to be 25. So the front and the back look fine, but you've got this unwanted middle term here, so that didn't work. So then somebody says, well, let's try canceling by putting a plus 5 and a minus 5. Now, that has a feature that's kind of nice. We get your 36x squared here. Your 30x and minus 30x cancel off. That's good, because you don't see a 60x or something like that there. But you don't get the right number at the back. It's minus 25. And this is plus 25. So what we've just discovered is that this does not factor. You write prime next to it. A sum of squares does not factor. Okay, and that does it for page 4 of the review.